Good evening. I'm calling from the Barbados National Medical Society in Barbados, the Harry Observatory. And tonight we are going to discuss the colonization of Mars, the colonization of the red planet. Now, tonight begins a series of astronomical programs, hopefully continuing over the next couple of months, that will deal with various subjects pertaining to astronomy. This week, we'll be dealing with Mars, the colonization of Mars, the red planet. Because this week, indeed the last couple of days, at least 3 robot missions were launched toward Mars. Now, these missions add to a growing number of space missions, robotic missions, that have been visiting the red planet in the last 2 or 3 decades. The ultimate goal being to actually land a man on Mars and to colonize Mars as our first step, or at least the second step, toward the colonization of our solar system. On July 21st, the UAE launched their HOPE spacecraft. The HOPE spacecraft was launched towards Mars. So this is the first space mission that the UAE has launched to any body in space. And they have chosen Mars because Mars is indeed the planet that will occupy the attention of scientists and technicians and engineers during the century. Now, the UAE spacecraft, the probe, called the HOPE, was launched from Japan using the Japanese Mitsubishi rocket that you can see here in the actual photograph. The second one to go was the Chinese Tianwen spacecraft. This is an extremely ambitious space mission using the Japanese, the Chinese Long March 5 rocket. This rocket is is the heaviest lift rocket that is in the Chinese arsenal right now. And it is basically intended to send a spacecraft, a robot spacecraft, to Mars. And that spacecraft has 3 components: the orbiter, the lander, and the rover. Now, this is extremely ambitious because it's the first time that any country will attempt in its first try to actually orbit, land, and rove Mars within the same mission. The United States, at this point in time, NASA, has a number of rovers and orbiters actually on Mars. But if China is successful, there will be the second country to be able to orbit, send in one mission an orbiter, a lander, and a rover. So good luck to the Chinese in their attempt. This was launched on the 30th of July, within days of the HOPE launcher. And following on the 30th of July, a couple of days ago, were the Americans. The Americans launched, you can see the launch here using the United Launch Alliance's Atlas V rocket that put the Perseverance spacecraft into the Mars transfer trajectory. There were initially some difficulties with the spacecraft in terms of communication. Apparently, the spacecraft actually encountered temperatures that were lower than were expected and went into safe mode. Hopefully, these obstacles can be surmounted and the spacecraft can be free to pursue its mission to Mars. Now, you may ask the question, why all of a sudden during the last week or so were all of these launches attempted? And the reason being is that Mars, as you can see here, is in a favorable situation to Earth, a favorable position to Earth, less than 35 million miles. And indeed, Mars is on average about 48 million miles from the Earth when it is at its near point. But this year represents a particularly favorable year for launching toward Mars. And the spacecraft that are going to Mars are using what we call the Hohmann transfer orbit. This is developed by an astrophysicist called Hohmann, who basically designed a way of transferring a spacecraft from one elliptical planetary orbit to another elliptical planetary orbit. And you can see here, the spacecraft itself basically is, the spacecraft is on its way to Mars with this transfer orbit. If you follow my pointer, this is a transfer orbit here leading that will terminate at Mars's space. In other words, the spacecraft will transfer from Earth orbit into Martian orbit. Now, I must point out here that these spacecraft will have orbital trajectories and orbital speeds that are much higher than the orbital speed of Mars, because Earth revolves around the sun at a much higher rate than Mars does. So basically, Earth will have, Mars will have Earth will have the ability to surpass Mars in its orbit, and any spacecraft leaving the Earth going to Mars will have that initial velocity greater than Mars's orbital velocity that will enable it to reach Mars. In this case, in 7 months' time. So in 7 months' time, you will have a situation where these spacecraft will be in Martian orbit and will be basically able to pursue the mission around Mars. So this is an optimum time for visiting Mars. Now, I must say here that the European spacecraft, there were supposed to be 4 spacecrafts, but the ESA spacecraft, the European Space Agency spacecraft that were supposed to be launched by a Russian Proton rocket, there was some difficulty, some technical difficulties that delayed that launch, and they have missed that launch window. So they'll have to wait now until 2022 before their spacecraft can be launched. So this is a great disappointment for the ESA, but that is the way things go when you are doing orbital transfers. Now on to Mars. Mars was, the recognition of Mars as an object in the sky goes back thousands and thousands of years. The Chinese call Mars the fire star because of its red appearance in the sky. The Greeks named it after their god of war, Ares, and it is the Romans that basically named it after their god of war, Mars. So we see here Mars, the red planet, being historically associated with war, and you know, and being the object in the sky that was most interesting to not only the ancient astronomers, but also modern astronomers. In modern times, after the telescope was invented and spacecraft began to investigate Mars at close range, we see here that Mars is roughly the planet, the only planet that is even roughly approximate to Earth in terms of its environmental conditions. And this is making a very broad and very vague statement, because Mars is an extremely hostile environment. In this photograph here, you see that Mars shares something in common with the Earth in that it has a polar cap. It has 2 polar caps. You're looking at the northern polar cap, and there's also a southern polar cap also. And those polar caps are made of frozen carbon dioxide and water unlike the Earth, whose polar caps are entirely water. Now, it has been conjectured by astronomical investigation, by spacecraft that have been visiting Mars for the past 50 years or so. It has been conjectured that Mars at one time had a climate and conditions that were very much like Earth's. We suspect that Mars had a massive ocean that covered over half its northern hemisphere. It had abundant atmosphere of oxygen and nitrogen and so on. And for some reason, which we have not yet completely identified, Mars has now become a very arid planet. And we suspect that because Mars's core was not very active, because it is the spinning iron core of a planet that produces the magnetic field that protects that planet from the radiation from its parent star and also from the rest of the galaxy. The Earth's magnetic field protects the Earth from solar radiation and from cosmic radiation. Mars was not that lucky. Mars's tectonic activity, diminished some 100 million years ago, and that allowed the radiation from the sun to blow up Mars's atmosphere out into space. And with the loss of the atmosphere came the loss of all of Mars's surface water. Now, all was not lost, because we have discovered that Mars has abundant resources of frozen water under its surface. So all the surface water is lost, but the subsurface water is still present. That is very good news for the colonization of Mars, because then the colonists can use that to supply their colonies and so forth. Now, the atmosphere of Mars is still there. It is, albeit a very, very thin atmosphere. Actually, the atmosphere of Mars is only about 1% of Earth's atmosphere. You can see Mars's atmosphere there. It's only 1% of Earth's atmosphere, 1%. It consists mostly of carbon dioxide, which is 95.3% carbon dioxide, less than 0.174% oxygen. The rest is water vapor and argon. So astronauts, colonists, future colonists landed on Mars will not be able to walk around in shirt-sleeve conditions. They will have to be clad in spacesuits that are impervious to radiation and to dust and so on. I will get to that later on. But don't be carried away by what you see in the movies and so on. But astronauts cavorting on Mars, that will not be the initial experience for the colonists arriving on Mars in the next 10 years or so. They will have to be sheltered in very heavily armored conditions to protect them from the solar radiation, the cosmic radiation, micrometeoric impacts, and so on, that are a characteristic of the Martian environment. If we look at some features here on Mars, we can see that Mars is dominated by a massive feature called the Valles Marineris. This is a huge trench akin to the Grand Canyon in the United States, but it is many times larger than the Grand Canyon. This feature is about 4,000 miles long, 300 miles wide, and 4 miles deep. It's a huge structure. We believe that this occurred when Mars was cooling about 3 billion years ago, and the surface split open, causing this huge valley to be formed. It's called the Valles Marineris trench. And it will be of significant interest to any search for life on Mars, because if there's any niche that Mars still has that will support life, it will be in the vicinity or within the confines of this Valles Marineris Trench, because that deep below the surface, 4 miles deep, the atmospheric pressure might still be sufficient, and the conditions might be sufficient, being that near to the water table, that life might have carved out some niche in the hostile Martian environment. So that is something to look forward to. And certainly the future colonists will be paying tremendous attention to that. Now, in addition to that surface feature, there is another one, and that feature is called the Olympus Mons. Here's Olympus Mons. It is the largest volcano in the solar system. This thing is about 15 miles high, right? Remember that Mount Everest is only about 5 miles high, and it's 374 miles across at its base. That means that if you were to put one end of the base of that volcano next to Barbados, the other end of that volcano, the other side of the volcano, will be stretching as far north as, or far away as Dominica. This is a huge, huge system. It is the largest known volcano in the solar system, and well, scientists believe that this volcano might still be active, although it's probably not erupted for the past few thousand years or so, but it might still be active. Who knows? If it does erupt, it will cause tremendous amount of concern to any colonists who might be on Mars, because this will be an eruption of huge, huge proportions. And you know, you wouldn't want to be anywhere in the vicinity when this thing goes off. But that is one of the dangers to be faced in colonizing this new frontier, Mars. So if you were to take Mars now at its most controversial, back in 1976, when the Americans landed the first, well, successfully landed the first, because the Russians landed the first probe on Mars, but that was not successful in sending back information. When the Americans landed the first successful probe on Mars, the orbiter for that mission took this picture, and it was a picture of what was then thought to be a face. It caused great controversy on Earth and among the scientists, the scientific community, but it was later discovered or resolved to be by spacecraft, future spacecraft, using high resolution cameras and so on, to be a landform, a rock structure that has occurred naturally rather than an artificial construct. That is still to be resolved, by the way, and no spacecraft, no probe has landed close to this construct to see whether or not it is artificial or whether or not it is natural in origin. And this is some of the mysteries of Mars, and this is what makes Mars so intriguing to scientists and astronomers all over the world. This face is located in a very interesting area of Mars. It is called the Cydonia region. And the Cydonia region not only contains the face on Mars here, but also a construct here that we call the city. And the next area here is what appears to be a 5-sided pyramid and so on. So this area will be the scene of very much activity and investigation and so on by future colonists who will be colonizing Mars in the future. Certainly by the first half of the century, by 2050, there will be an established colony on Mars, and they would be basically investigating areas like these where there is some interest in terms of what Mars, what the past, the history of Mars would have been as it relates to intelligent civilization. We are not shutting the door on intelligent civilizations on Mars. We do not know enough about Mars yet to make that that definitive decision to basically close the door on whether Mars had intelligent civilizations or not in the past. Now, in order to get down onto the surface of Mars, the spacecraft has to lose all of its energy that it was injected to it during the Earth launch, and to come to a standstill basically on the surface of Mars. The Americans call this 7 minutes of absolute terror, because within those 7 minutes that it takes to get for the spacecraft to get from the top of Mars's atmosphere to the bottom of the atmosphere on the ground is 7 minutes, and that 7 minutes is entirely critical to the success or failure of the mission. Many spacecraft have crashed on Mars, having failed to negotiate this phase. And as a matter of fact, only 50% of all spacecraft that were actually sent to Mars actually succeeded, only 50%. And a lot of them failed in this particular aspect of the descent, because although Mars's atmosphere is exceedingly thin, only 1% of Earth's, a spacecraft traveling at over 12,000 miles an hour can create a tremendous amount of friction descending through the atmosphere, and the temperatures will be in excess of 5,000 degrees Fahrenheit, and that is, if the spacecraft is not properly oriented and so on, it can actually burn up. The mission can fail. The chute can fail to open. The descent engines can fail to fire, and the mission can be destroyed, can be ended in a matter of minutes. And the thing about it is that the mission controllers are always about 25 minutes behind what is actually happening, because the signals from Mars take around 25 to 29 minutes to reach the controllers back on Earth. So everything is happening. What they're seeing in control is 25 minutes in the past. So while they are wondering what is happening with the spacecraft as it descends to the atmosphere, it has already happened. Okay, so that is one of the what should I describe it as, the terrifying aspects of sending a spacecraft to Mars. All of that money invested can be ended in just 7 minutes of that descent. Now, having descended on Mars, there are a number of interesting features to look at. And the features to look at, basically, first of all, the landing sites. This is where the Phoenix landed. The Phoenix spacecraft landed near to Mars's North Pole. That discovered ice just inches under the surface of Mars. The Viking 2, which is the first, and the Viking 1, which is the first spacecraft to actually successfully land on Mars in the Morris Vallis region. The Pathfinder also landed there. Opportunity, which is a rover on Mars. These are actually all lake and river basins that, if there's any life or any fossilization, any fossils on Mars, they will likely to be found in these regions. And these are also regions that the future colonists on Mars will want to land also. And if we take a closer look here, you will see that here, these are regions here that the bluer the region, the more suitable it would be for landing sites, proposed landing sites for future colonists. The red zones near to the volcanoes are obviously not suitable, and you would want to go near there. But certainly the bluer zones, which are zones that are where water or ice is pretty near the surface, that the astronauts can electrolyze into water for drinking and bathing and so on, and for growing plants, oxygen for breathing, and hydrogen for fuel. And so this ice is extremely important for any cultivation or any colonization of Mars in the future. And you can see here on the scale of 1 to 10, 10 being an excellent landing site, that places like the Arcadia Planitia are optimum sites here for landing, and basically any future landing sites for colonists will be in these regions, in the northern regions of Mars. And here is an artist's impression of a landing site as it would look at the first base that would be set up on Mars. You can see here the astronauts and the rovers, the rover part near to this base camp. Now, this is simply an artist's impression. When we look here now at this particular rover, this rover, the Curiosity looks like this one. This is the one of the rovers that are actually now roving around Mars, looking for life on Mars, looking for potentially good sites to be landed, to be utilized, and so on. And these are the forerunners of what will be perhaps hundreds, thousands, and even millions of human colonists that will follow during the course of this century. These rovers will be are the forerunners of the human colonists that will follow. And the information that they're sending back to Earth is intrinsic in the determination of where we will land on Mars and and what conditions we will face on Mars when we get there. This is a prototype. This is a NASA prototype of the rovers that will be used to get around Mars. Now, I said earlier that astronauts will not be able to walk around Mars in even in space suits for any long period of time because of the radiation, because of the dust storms, because of the micrometeorite impacts, because of the poisonous atmosphere or lack thereof on Mars. And it is extremely likely, well, not only likely, but necessary, that they will be driving around in vehicles like these. These vehicles can be described as spaceships on wheels because they will provide the same kind of protection that a spaceship provides an astronaut when he's traveling through space. These vehicles will be providing those same protections that the astronauts will have to avail themselves of when they're exploring Mars. This one tends to be very futuristic. It's not really my favorite. This one is my favorite, and these rovers were part or designed for these rovers, was commissioned by NASA, and there are various companies that basically designed these rovers and submitted them to NASA for evaluation. And this rover was designed by a company called Ergonomic Systems. And it is my favorite because it is a very practical design. And you can see here that the rover has robotic arms that can basically take up various samples of materials in Martian surface and transport them into an onboard facility where they will be examined by the the explorers on board. And you can see here the vehicle itself is divided up into compartments. This compartment here is the control deck. This is where the colonists, the explorers, actually control and drive the rover. This area here is the crew living quarters, where the crew actually lives and take their meals and so on. And this is the lab, okay, where the various scientific research and the examination of Martian samples are conducted. The astronauts will, the colonists, you need to call them colonists, will be accessing the rover through this area here. This segment, this module, is actually an airlock through which the colonists will enter and exit the rover. And here is an example of the rover, which is outfitted now because it is modular. The rover can be outfitted for any particular task. So this task now, in this task here, the lab module is being substituted for a crane, which is lifting a rover off the ground or deploying a rover. And the crew compartment is now a service compartment where the rovers are being serviced and so on. And you can see here, this is an example where the astronaut is, where the colonist is actually using a drill that is plugged into a radioisotopic nuclear generator, which is modularly fitted to the rover and will provide power for the rover. Now, these rovers are designed to have ranges of over 500 kilometers, being able to stay out from the base for days on end and to explore Mars over a wide area. So this is the means by which the colonists will explore Mars in the future. And you can see here an interior view of the rover. And you can see here, this is the navigation suite. This is the science suite here that the various colonists, the scientists on board, will be using to in their investigation and their scientific study of Mars. And to your left here, you can see where the entrance door here from the airlock, where the astronauts will go through to get to the surface and re-enter the rover through this airlock. And this is a beautiful view here from what will be the controllers or the driver's chair. And you can see here, the driver has an almost unobstructed view of the Martian terrain. And there will be two persons on the control deck. One will be the driver. The other one will be the person who will be controlling the robotic arms and doing all the scientific study and so on. Now, it comes to living on Mars. If you are going to be on Mars, you have to be able to live comfortably and live safely. Now, it has been designed, NASA again sent out RFPs for various technical organizations to design habitats on Mars. The current strategy is to basically send robots to Mars in advance of any human civilization, any human colonists going to Mars, that will 3D print structures, living structures on Mars. Now, this is an example of a structure that has been 3D printed, right? And this structure that has been 3D printed basically is one that is suited to the protection of the colonists on Mars. And the colonists must be protected because, obviously, as I said before, there's radiation from the sun, there's radiation from the rest of the atmosphere of the galaxy, sorry. And basically astronauts will have to be protected 24/7, right? And that is an Earth term that I'm using here, but you get the drift. The astronauts must be protected throughout the Martian day and night from these dangerous events. Also from the massive periodic dust storms that occur on Mars. Mars suffers from huge dust storms. Although the atmosphere is very, very thin, the nanoparticles that make up the dust on the Martian soil can be picked up by these very light winds and transported all over the globe. Now, recently we've been having an experience here in Barbados where the dust from the Sahara Desert was picked up by winds and transported thousands of miles across the Atlantic into the Caribbean, into North America, into Central and South America. And it was of much discomfort to most people in these areas. And indeed, it even tempered the weather that we were experiencing in this region. Now, this happens on Mars on a massive scale, of many orders of magnitude greater than what happens on the Earth. And these dust storms on Mars can basically surround the entire planet for weeks on end. And this is what the Mariner 9 spacecraft that visited Mars back in the late 60s, early 70s discovered, that Mars is covered by huge clouds of dust. And these dust grains are actually nanoparticles. So basically, an astronaut that is unprotected can find that dust, can actually find its way into his suit, into his or her suit, if it is not properly protected. And that dust can be inhaled into the astronaut's lungs with deleterious effects. So we are basically very concerned as to the construct or the way how we will protect astronauts on Mars, because it is extremely essential for the survivability of the Martian colonists that they be protected from these environmental hazards. And you can see here, this is one example, this igloo-shaped structure that is so constituted, it will be 3D printed by robots on Mars, and by the time the colonists get there, they will only have to do the finishing touches, painting the insides and so on, and installing the equipment. But these structures will already be in place by the time the astronauts get there. And you can see another example of these structures as we get more expansive, more creative in how we create these structures. And this one created by Marshall Design was another one that was submitted to NASA. This is a winner, actually. And this one basically is made of materials that is resistant to dust, resistant to radiation, and entirely hermetically sealed against the poisonous Martian atmosphere and so on. So that would be absolutely essential for the initial visitors to Mars. And here is a shot of the inside of what would be a Martian, colony habitat. And you can see the scientists in there doing their various work and so on. And here is another view of what, and all this could be a reality within the next 25 years or so. Certainly, there are plans to set the first colonists on Mars by at least 2030. Between 2030 and 2035 will be the earliest that we will see a colonist on Mars, and the colonists must be, ready to live in environments like this and to have this level of protection in order for their survival to be assured. And here is what it might very well look like in 30 years or so when colonists begin to arrive on Mars in great numbers. We know that, for example, Elon Musk, using his Starship fleet, plans to have at least 1 million persons on Mars by the end of the century. And if that is to happen, there must be a very aggressive advance in technology, both in propulsion technology, both in life support technology, and in robotics and construction and so on. All of these technologies will have to coincide in order to make scenes like what you're seeing here happen. And this is most likely what will be the case in about 20, 30 years' time. Certainly by the end of the century, this will be a useful feature on Mars. And by the end of this century, when all of our technologies related to Martian colonization will have evolved, this will be the product of it. Cities on Mars, vast cities hosting hundreds of thousands, probably millions of people scattered across Mars. And thus will begin our true colonization of the solar system, stepping in from the moon to Mars, to the asteroid belt, to the moons of Jupiter and Saturn and Uranus and Neptune, and then the jump to the stars. But here will be the first steps, actually, in colonizing the solar system. And if we are successful in colonizing Mars, if we are successful in creating a new and additional habitat for the human species, then we can be assured of going out into the galaxy and being as successful as we were in the solar system itself. Okay, so thank you very much for listening to me. Hopefully we can provide some more insight into the newest space exploration events, and you will see us here soon again. Please click on the like button if you liked what you saw here, and we will see you again on the Barbados Astronomical Society's site. Okay, so thank you very much, ladies and gentlemen, for joining and listening to me. Thank you.